The first thing we're going to want to do is to install JetBrains IDE IntelliJ so that we can work with our Kotlin code on our development machine. Now the first thing to do is to open up your browser and search for IntelliJ. Here you should see a download link, and we can click on that to be taken directly to the download page. Now I'll be working on a Mac, but IntelliJ is available on Windows and Linux as well. You'll also notice here that there are two different versions of IntelliJ. There's the Ultimate Edition and the Community Edition. The Ultimate Edition has a lot more features than we need and is also a paid product. The Community Edition is supported for JVM development and Android development, so it's perfect for what we want to look at in this tutorial. When you're ready, go ahead and click the download button, and that should start the download. Once the download is complete, we'll get started on installing the IDE, and we'll take a look at Hello World in Kotlin. Now that our download's complete, we can go ahead and launch the installer. And on Mac, we'll drag the application into our Applications folder, which will start the install process here for us. Once the files have been transferred to your machine, we can go ahead and start IntelliJ for the first time to start the install process. In this case, we want to do a fresh install, so we'll click Do Not Import Settings and hit OK. Go ahead and accept the privacy policy, hit Continue. Now here you can choose your theme. I'll choose the dark theme. Go ahead with the standard IntelliJ key settings here. And we'll go ahead and click Next through to finish the setup process. And then we'll finally launch IntelliJ IDE Community Edition. The next thing that we want to do is create our first Kotlin project here in IntelliJ. So to do that, we'll click on Create New Project. Now over on the left side of this panel, we'll see a number of different project templates to choose from. Because we are going to be learning about Kotlin, we want to make sure that we have selected the Kotlin template. Now within this, there are a number of different Kotlin project types that we can choose from. The default here at the top is a Kotlin module for a JVM target. So this would be sort of a standard just Kotlin project that could target the JVM, nothing else added to it. Other examples would be Kotlin module for a JavaScript target, or a Kotlin native target, or an Android or iOS mobile target. So all of those are interesting, but more advanced. For this, we want to just stick with the basics. So we will make sure that we have selected Kotlin module for JVM target and go ahead and hit Next. Then we want to make sure that we name our project something meaningful. So in this case, let's call it Hello Kotlin. We'll make sure that our project location is set, and then we'll go ahead and select Finish. Now we have an empty Kotlin project. Let's start by adding our first Kotlin file so that we can write a simple Hello World example. So to do that, we'll come over here to the left, and here we have the project panel within IntelliJ. You'll see at the top we have our Hello Kotlin module. If we expand that, we can see that we have a source directory, but it's currently empty. Let's right-click on Source, go to New, and then Kotlin File or Class. And here we're going to type main for the name of our file, and then we will leave this as file so that we can create our main.kt file. Now we can get started by writing our main function here in our main.kt file. So to start, we'll type fun main, no parameters, and then we can type println parentheses hello Kotlin. And from there, you'll see now that we have this little green arrow. IntelliJ recognizes that this is an executable main function within this Hello Kotlin module. So we can actually go ahead and run this. We'll select Run Main.kt. And that'll take a second to go ahead and build the project. And then we will get our output window here at the bottom, and you can see that we have Hello Kotlin. Now, one extra quick fun fact here, IntelliJ comes with a number of live templates built in. This means that you can type something and it will know how to complete that and auto-generate some code for us. So we can start typing main and then hit enter, and it will automatically generate a main function for us. And then we are free to fill in with our Hello Kotlin text. Awesome. You've just written your first program in Kotlin. Now let's dive in and start actually learning the language. To get started, let's look at how you can define variables in Kotlin. Now there's two types of variables in Kotlin. We can define mutable variables, which can have their values reassigned. Those are declared using the var keyword. Or we can define local read-only variables, which can have their value assigned only once. These are defined using the val keyword. So to define a variable, we can use the keyword of our choice. So in this case, we use val. Then we'll define the name. And then we need to indicate the type. In this case, I'll say of type string. And then you can use an equals, and then you can assign the value to this variable. So in this case, I've defined a variable called name of type string, and then I've assigned the string literal Nate to that variable. Now, like I mentioned, val are assign once variables, meaning this is read only once it has a value assigned to it. So if I try to update the name of this, we'll see that we get an error. That error says val cannot be reassigned. So this is our indicator that if we need to be able to update the value of our variable, we're not going to be able to use a val. Instead, we could use a var. Now, var variables can be reassigned as many times as you want. So as soon as I updated that keyword, now I can update the value of our name variable. And then if we want to use that variable, we could pass that in to the print function here. And if we then run our main function, we'll now see the output value of that variable at this time is blank because we'd reassigned it. If we remove that reassignment, we'll now see that we get this little underline saying variable is never modified and can actually be declared immutable instead using val. So this is nice that the IDE gives us that helpful hint. So in this case, we'll go back to a val. And now if we rerun this once again, we'll now see that my name was printed out to the console. In this example, we're using a local variable, meaning that the variable that we have defined is available locally within the current scope. So in this case, it's available only within the main function we have defined. Now in Kotlin, you can actually declare variables outside of any type of enclosing function or class. All you have to do is declare a variable within a Kotlin file. So in this case, we've moved our variable name outside of the main function into the main.kt file. Variables defined like this are referred to as top-level variables. And you see now that we've moved this outside of the main function, we can still run it, and our variable is still completely valid. Top-level variables can be worked with just like a local variable. So we can define an additional variable. This time we'll say var greeting of type string equals hello. We now have a publicly available top-level variable called greeting. So now if we wanted to come down here and print out a greeting before the name, we could do that by calling println and passing in greeting. We could also modify that greeting because this is a mutable variable. And if we then print out this new value, we will see that the message has changed. So when we hit run here, we should now see hello Nate and then hi Nate. Let's take a closer look at how variable types are defined. So when defining our variables, in both cases, we use either the val or var keyword, and then we have the variable name. Both of these are must-haves. Next up, we have the colon and then the type. So in this case, we have the type of string, and then we assign our value. One interesting difference between Java and Kotlin is that types in Kotlin are non-null by default. This means that there is a distinct difference between string and a nullable string. Now, what does this look like in practice? Well, in this case, because types are non-null by default, name is a non-null string. So if I try to assign a null value to this, we'll actually get an error. And it will hopefully say null cannot be a value of a non-null type string. So if you want to actually have null as a valid value for your variable, you need to add a question mark after that string value. This indicates that now name is a nullable string, and I can assign null, or I can go ahead and assign an actual value. So let's look at how we could use this with the greeting variable. So if we make greeting a nullable variable, we can come down here and we'll go ahead and print out the default greeting value, we'll print out the name, and then we'll see that we can modify the value of greeting to null. And then we can go ahead and print out these values once again. And we can then see that greeting has been updated, and when we try to print that out, it actually recognizes that it's null and prints that out to the console for us. So let's look at how we can actually simplify the declaration of our variables. I mentioned that val or var, as well as the name, are mandatory. However, Kotlin supports type inferences on variables and properties. What does this mean? Well, this means that Kotlin can recognize what type the value is that we're trying to assign to the variable. And if it can figure that out, we can actually omit the type declaration of the variable. So in this case, we could actually remove the colon and string, and the name variable will still be of type string. Now we can do the same for our greeting variable. So we can remove this, but if we come back down here and try to assign null to greeting, we'll get an error. Null cannot be a value of non-null type string. So why is this? Well, again, because types are non-null by default in Kotlin, and we are assigning a non-null string literal to greeting, the compiler infers that greeting is meant to be a non-null string. So if you want to have a nullable string, you might try and just assign null. However, we get a warning saying implicit nothing type. This is because greeting now cannot really be inferred. It doesn't know what it is a null type of. So in this case, we will need to go ahead and specify a nullable string. Now down here, we can assign null to greeting, or we could assign an actual greeting. Now that we've taken a look at how to create variables and how the type system works, let's introduce some basic control flow. And we'll do this by working with the nullable string variable of greeting. So let's go ahead and remove these values. Now let's say that we only want to print out the value of greeting if it's not null. So we could do that in a couple different ways. The first one we'll look at is using an if statement. If statements in Kotlin work very much the same way as in Java. So we'll use the if keyword, followed by parentheses. We'll use greeting. In this case, we want to say if greeting is not null, print it out. So we can say not equal to null, and we'll finish it off with curly braces. And then if we move our print statement within that if conditional, when we run this, we should now have no greeting printed out. And sure enough, we see that just the name is printed. And if we modify the value of greeting to be non-null and then rerun this, we'll now see that we have our greeting. Now, what if we wanted to add an else clause? So, just like Java, we could add an else. We can add curly braces again. And so here, we could define a default greeting of hi. So now, if we run this once again, greeting will be null. And so we should see the default hi value. Now, another means of control flow within Kotlin is the when statement. The when statement is very similar to a switch statement in Java. So to create that, we can come down and use the when keyword and then parentheses. We then want to pass into this the value that we want to check and switch on depending on its value. So in this case, we'll pass in greeting followed by curly braces. Now within this block, we can define each value that we want to act on differently. So in this case, we could say null, and then to define what action to take, we use an arrow, and then we'll say print line hi, and then we can define an else case here, and this will act as the default if none of the values above are matched. So in this case, we will print out the value of greeting on its own. So now, if we run this, we should see hi printed out because greeting is still null. And once again, if we update greeting to be some other value and rerun, we'll see that the else branch of the when statement is hit and we are printing out the value of greeting. So these are two of the basic ways in which you can manipulate control flow within Kotlin. Now we just saw how if and when can be used as statements to take different actions based on some checked value. If and when can also be used as expressions to assign a value depending on those logical conditions. So let's take a look at how we could use an if expression to assign a value to a local variable. So let's go down here and type val greeting to print, we could say equals. Now, if the greeting variable in our top level declaration is non-null, then we want to go ahead and stick with that. So we could say if greeting does not equal null, then we want to assign greeting to the new greeting to print variable. Otherwise, we want to say hi. And then we'll update our print line to use the local variable. Now when we print this out, we should see the else branch of hi being printed out. This is because the top level variable is currently null. If we modify this to pass in a greeting, now if greeting does not equal null, we'll return true, and we'll see that hello is printed out instead. So if we want to assign different values to a variable depending on whether or not something is null or some other logical check, we could use an if expression. However, we could also use a when expression if we wanted. So we could say when, and again, we'll pass in greeting here. And again, we'll use our null value as the first check. And if it's null, we'll go ahead and return hi. Otherwise, we'll go ahead and return the original greeting value. So now what this when expression is saying is assign the value of hi to greeting to print if greeting is null. And likewise, if greeting is non-null, go ahead and assign that value to the new greeting to print variable. So if we run this one more time, we should see hi because greeting is null. And if we assign a value to greeting and rerun, we'll see that updated value of hello. So again, like the if expression, a when expression can be used to assign a value to a variable depending on that input value that it's checking. Let's look at this example. Within this example, we actually are using two different functions. We have our main function, and then we're also using the println function as well. So let's take a look at how we can define our own new function. We'll start by clicking here. And we'll define a new function that is going to return the string that we want to print out to the console. So the first thing to do when defining a new function is to use the fun keyword. This denotes that we are going to define a new function. Then we want to specify the function name. So I'm going to call this function getGreeting. And then you want to follow that up with open and close parentheses. And within this, we can actually define any function parameters. Now, for now, we're going to skip any function parameters, and then we want to define our return type for this function. So similarly to variables, we can define a return type by using a colon, and then the type, in this case, string, and then we'll do open and close curly braces. Now, like in Java, we can define the return value by saying return, and then in this case I'll say hello Kotlin. So now we have a function called getGreeting that is going to return the string hello Kotlin. If we want to then invoke that function, we could do so by calling getGreeting with open and close parentheses. This should look very similar to what you're familiar with in calling methods from Java. And now, if we run our code, we'll see two print statements. We'll see the first one, hello world, and the second one, hello Kotlin. So one thing you may have noticed is that in our getGreeting function, we're specifying the return type of string. However, in our main function, there's no return type specified. So why is this? Well, let's illustrate this by an example. Let's write a function called say hello. So again, we'll use the fun keyword, and then we'll name it say hello, no parameter values, and then we're going to declare this as returning type unit. Unit in Kotlin is essentially the absence of any useful type. It's similar to saying this returns nothing useful. And the reason we're going to use unit in this case is because we don't want to return anything. We're going to simply print out our getGreeting function's return value. So we can then call say hello, and you'll notice up here that unit is underlined. And it's giving us this message that says redundant unit return type. Basically what this is saying is that if you have a function that returns unit, that is to say if you have a function that doesn't return anything useful, you can omit that type value. So we can actually remove unit from our sayHello function, and this is perfectly valid. So that's why in our main function, we also don't have a return type specified. Aside from the rules around unit return types for functions work very similarly to how you would define them and treat them for variables or properties. So for example, if we wanted to return a null string from our getGreeting function, we would modify the return type to be a nullable string, and then we could return null in our return statement. Additionally, functions support type inference as well. So, in our getGreeting example here, we are returning a single string literal, in which case we could actually simplify this to a single expression. We could remove the curly braces and add an equals and then the string literal after that. So this is what's known as a single expression function, because the entire function definition is now in a single expression. And now this is where the type inference comes into play. Again, because the compiler understands this single expression function definition, and it knows that it's always going to return a string, we can actually remove the explicit return type. Now, our getGreeting function is extremely simple and is functionally equivalent to the previous definition. So if we run our code once again, we'll see that we now have our 3 different print statements. You might be noticing a theme here of Kotlin allowing us to reduce the amount of code we need to write to get the equivalent functionality. This is a theme that will crop up more and more as you start to learn the language. Now let's take a look at how we can define function parameters. Now before we get started, let's clean up our code a little bit. So we'll remove everything from our main function, and we're going to go ahead and remove the existing function examples we've been working with. So once again, we're going to define a function named sayHello, and to start, it will print out hello Kotlin. Now this is exactly like we have seen before. But what if we wanted to change the thing that we were greeting? So instead of saying hello Kotlin, maybe we wanted to say hello world, or hello Nate, or hello John. So how might we do that? Well, that's where a function parameter comes into play. So to define a function parameter, we'll go within the parentheses after the function name, and we'll define this using a notation of the parameter name, colon, the parameter type. So in this case, we're going to say item to greet as our parameter name, colon, and then we want this to be a string value that we're passing in. Now, within our function, we could say val message equals hello plus item to greet. And then we could pass in the message. Now if we come down to our main function, we want to invoke sayHello. So we can start typing sayHello. And now we need to pass in a parameter value, which it suggests to us in this little tooltip. So in this case, we'll say Kotlin. And now if we run our main function, we now see hello Kotlin is printed out to the console. If we wanted to print out something else, we could duplicate the invocation, and maybe this time we'll pass in world. And if we invoke our main function again, we'll now see hello Kotlin and hello world printed out to the console. Now, if we go back up to our say hello function, we'll notice that there's this squiggly line here. This is unrelated to function parameters, but this is a really interesting feature in Kotlin. Kotlin supports string templates, which allow us to substitute in variable values or argument values into a predefined string template. So in this case, instead of using concatenation, we could say hello space, and then to define a templated value, we use a $, and then we can pass in the parameter name. So now, if we hit run once again, we'll see the same output as before. So this is just one more way in which Kotlin can reduce boilerplate for us by allowing us to define these convenient string templates. In fact, in this scenario, we could take it one step further and remove the local variable altogether. And then we could actually take this one step further and define this as a single expression function. Now we have a say hello function that will take in a parameter value, which is the item to greet, and then it will always print out hello item to greet. So now let's update this to take 2 parameters so that we can customize both the greeting and whatever it is that we want to greet. So to do that, we're going to add a new parameter, and we will name this one greeting and have it be of type string. And now we will update our string template here to include that new parameter. Awesome. So now we've updated the function. Now we need to update the invocation of that function. So for this first line, we could say, hey, Kotlin. And now for the next one, we'll say, hello, world. And if we run this, we'll now see our desired output. So by adding that second parameter value, we have now made our say hello function much more flexible. Now we can add any number of parameters we want to say hello, but like any programming language, if you have too many parameters in your function, it might be an indicator that your function is doing too much. Now, one last thing I'd like to point out about functions at this time is that you'll notice that these functions are not defined within any type of enclosing class. These are free functions, or as they're referred to in Kotlin, these are top-level functions. Like variables, functions can be defined outside of any enclosing class or independent of any associated class. Now, there are types of functions that are associated with a class, and we'll take a look at those later on in the tutorial. Like most programming languages, Kotlin has support for collection data types. These are things like arrays, lists, and maps they can use to group values together and then operate on them at a later time. So let's start off by looking at how we can define an array in Kotlin. We'll clear out these invocations to say hello because we won't need them right now, but we'll leave the say hello function definition because we'll come back to it later. To create a basic array, we'll create a new local variable named interesting things. And then we'll use the equal sign, and then we can use a convenience function called array of, in parentheses. This will create an array of whatever the inferred type is. And then we can start defining values within this function. So in this case, as soon as I add a string literal, it can infer that this is going to be an array of strings. And now we can define some interesting things like Kotlin, programming, or comic books. Now that we have this variable defined, let's see what types of operations we can perform on it. If we start typing interesting things and hit dot, the IDE will start to autocomplete and show us some of the methods available. So you see we have a size property, we have a get method, and we also have this open and closed bracket syntax that we can use to access individual elements in the array. Let's try printing out some of these values to demonstrate how we can use the array. To start, let's print out the size. We can do that by saying println, and then we'll do interesting things dot size. Now let's print out the first element in the array. We can do that by going println, interesting things. We can use the open and close bracket, and then pass in an index. This is how we can conveniently index into that array. This is similar to doing a get. So if we duplicate that line, we could say get, and again, pass in the 0th element of that array. If we now run this, we'll see 3, Kotlin, Kotlin. This is just as we would expect. Now, what if we wanted to iterate over all of the elements of this array, and then perhaps print out each of those values? Well, there are a number of different ways we could do that. For now, we'll take a look at a basic for loop. So we could start typing for, and then we could say interesting thing in interesting things, then open and closed curly braces. This is now the convenient syntax of for loops within Kotlin. So this is going to iterate over each value in the array, and we can access those values in the interesting thing variable that we have defined within this for loop. So now we could type out interesting thing. And if we rerun this code, we'll now see that we have printed out each element in the array. So that type of for loop is what is probably most similar to what you're used to if you're coming from Java. However, in Kotlin, because we have top-level functions and higher order functions, and really just first-class support for functions across the board, we can write code that is a bit more functional. So let's take a look at how we could do a more functional approach to collection iteration. So we'll remove our for loop, and now we could say interesting things dot for each. And what this is invoking a for each function that is available in the standard library. That function then takes in another function and returns unit. That function that we pass in essentially defines what to do on each iteration over this collection. So within our curly braces here, this is where we can define what we want to do with each element in interesting things. Now, this might look a little bit confusing at first, but don't worry, we'll explain this. But if we simply want to print out each item in this array, we can now say println and pass in it. It is the default name for each element in the array that is passed into this lambda function in which we are defining. So if we run this, we'll now see that we have our 3 elements in the array printed out to the console. Now, it is not always very readable, so another little quick tip here is if you want it to be named something else, you can rename that value that's passed into the lambda. In this case, we could call it interesting thing, and then we'll use the arrow, and now instead of it, we can reference that value by calling it interesting thing. And once again, if we run this, we'll see that our interesting things are printed out to the console. You might be looking at this wondering why we are not using an open and closed parentheses when calling the for each function. In fact, it might seem rather odd that we are not passing in that argument to for each, but instead have just specified this open and closed parenthesis independent of the rest of the for each call. So this is actually what's known as lambda syntax within Kotlin. Now we'll look at how to implement this later, but the idea behind Lambda syntax is that if you have a function and its only parameter is another function, then you can omit the parentheses altogether, and you can pass that function in by specifying this open and close parenthesis. So again, if we look at for each, we'll see that it takes a single function as a parameter. So we can omit the parenthesis values and pass that function into the for each function using the open and closed curly braces. And like I said, we'll look at how we actually define this type of higher order function a little bit later in the tutorial. So here we've looked at a basic for each function on this array collection, but by doing it this way, we've lost the index data for whatever index the current interesting thing is in the containing array. So to handle that, there's another function we can call. So once again, we'll say interesting things, and this time we'll say for each indexed. Now this time, it's going to pass into us the current index as well as the current string. Now once again, we'll update this to be named interesting thing. And now once again, we could print out these values. So we could say print ln, and we could say interesting thing is at index. And now if we print this out, we'll see that we have gotten the value from the array as well as its current index. So this could be really useful if you need to iterate and still maintain that index data. Now, everything that we've been looking at here for arrays is applicable for lists as well. So if we clear out some of this previous code, we now go to our declaration of this interesting things variable. Now we're using the convenience function arrayOf to define this variable as an array of type string. Now there's also a listOf function as well. Now, if we try to work with interesting things, we'll see that we have a lot more methods to choose from because it's now a list rather than an array. And so like an array, we can access individual elements by using a get, or also by using the bracket syntax like we're familiar with arrays as well. And also like with the array, we have functions available to us to help with iteration. So if we wanted to print out all of the interesting things again, once again, we can say interesting things dot for each. And once again, we'll say interesting thing. We'll use the arrow here within our lambda expression, and then we'll print out the interesting thing. And if we hit run, voila, we have our 3 interesting things printed to the console. Now that we've looked at arrays and lists, let's take a look at one more collection type in Kotlin, which is map. So let's remove this iteration over our interesting things variable here. Now let's create a new variable, and we'll just name this map equals, and once again, there is a map of function that we can use. Now the map of function will essentially take in pairs. Pair is a simple wrapper class containing 2 values. And there's also a convenience function to create pairs. So if we want to create a basic key value map, we could do so like this. We'll use a key of 1, and then we'll use 2, and then the value in this case will be A. And then we'll define another pair. We'll use a key of 2, then we'll use the 2 function, and then a value of B. And then we'll define one more pair, and we'll say 3 is our key, 2, C. So what we've now done is defined a map with 3 pairs of values in it. The keys are 1, 2, and 3, and the associated values are A, B, and C. Now we can iterate over this by saying map for each, and it's going to return to us both the key and the value. Unfortunately, they default to a not very useful name, so in this case we'll rename them again within our Lambda expression. So we'll say key, value, and then we can print these out, and we'll use a string template, and we'll just say key, and then we'll define an arrow just for some separation, and then value. And now if we print this out, we'll now see that we're getting each of our key and value pairs, and then we could do with those whatever that we need to. We've seen how you can define several different types of collections, such as arrays and lists and maps, and we've also seen how you can iterate over those collections and access individual elements from a collection. And there's an interesting thing to point out about the way Kotlin handles the collections. Similar to the way in which it differentiates between nullable and non-null types, Kotlin also differentiates between mutable and immutable collection types. Now, what does this mean? This means that by default, a collection type in Kotlin is immutable, so that you can't add or subtract values from that collection once it's initially created. So let's look at an example of this. We have defined our interesting things list using the list of function here. And if we wanted to try and add something to interesting things, there's no function available to us to do that. That's because it's immutable by default. If we wanted a mutable list, we could use the mutable list of function. Now, if we want to add something, we can say interesting things dot add, and we could add a new string to our interesting things list. The same goes for map. If we wanted to add a new key value pair to our map, we can say map dot put, but there's no put method available. But if we change to mutable map, now we can say map dot put, and we can define a new key of 4 and a new value of D. So this is something to keep in mind. If you have a collection that's going to be static once it's defined, then you're fine to use the regular list of, array of, map of, etc. functions. And that is a good thing because immutability is often a desirable trait in your code. However, if you're going to want to modify the values in that collection, then you'll have to create a mutable collection so that you have access to things like put or add that let you modify that collection. Now that we have an understanding of working with collections, let's modify our say hello function to take a collection parameter so that we can greet multiple things. We'll modify first the name of item to greet to items to greet because it's now going to be plural because it'll be a collection. And now we'll update from string to list of string. And then now we're going to update the implementation of this function. So instead of being a single expression function, we'll add a function body. And then now we're going to want to iterate over the items to greet parameter. So we'll say items to greet dot for each, and then we'll paste back in our original print statement. And then we'll go ahead and update the receiver value here from it to item to greet. Then we'll add our arrow. And so now we have a say hello function that you can pass a collection into, and then it'll print out multiple lines. So now we could say hello, and we can still pass in our custom greeting. So we can say hi, and then we could pass in our interesting things variable. And now, if we click Run, we now see Hi Kotlin, Hi Programming, and Hi Comic Books. So this is just a quick example of how you can pass in a collection type to a function as a parameter. There's nothing wrong with including a collection parameter in your function. However, functions in Kotlin do provide an additional piece of functionality that can satisfy this use case and provides a little additional flexibility. Now, to demonstrate why this might be interesting to us, let's look at an example. So let's say we want to call say hello, and we'll pass in our greeting, but then we don't want to pass in any interesting things in this case. Well, because of the way that this function is currently defined, we have to pass in the second argument. So in this case, if we wanted to pass in no items, we would have to pass in an empty list, which isn't really a big deal, but it's also not the most flexible way of handling things. So let's take a look at an alternative means of achieving this functionality. If we come up here to our say hello function, we're going to modify this second parameter so that it is a var_arg parameter. Var_arg is a keyword in Kotlin that essentially represents a variable number of arguments. So in this case, instead of taking a list of string, we'll define a var_arg of string. This tells the compiler that we're going to take a variable number of string arguments after the initial greeting argument to this function. So now, if we try to pass something in to say hello, we'll first pass in our greeting, and now we don't actually have to pass anything in after the initial argument. This is because the var_arg parameter will essentially be treated as an array of whichever type it's used to specify. So in this case, items to greet is now an array of type string. So if we don't pass any items after the greeting, it will be treated as an empty array. If we did want to start to pass items, we could do that by separating them with commas. So we could say Kotlin, and now this would be an array of size 1. But where the real flexibility comes is we can now start to define many argument values here. And so now all of those arguments that are passed in will be grouped together, treated as an array. And so in our function implementation, we can still iterate over all the elements in that array. So if we now run this, we should get the same output as before. So by using our var_arg parameter, we've eliminated the need to always pass in a value after the initial greeting argument. It lets us have greater flexibility because it will support 0, 1, or any other number of argument values to be passed in. Now, it's very convenient to be able to pass multiple arguments to this var_arg parameter. However, you're usually not going to be hard coding those arguments in manually during compile time. More likely, you're going to get an array of values from a network request or a database, and then you're going to want to pass those in. So you might think that it would be as simple as passing in an array after that initial greeting. So let's try that. We could change list of to array of, and then after our greeting, we'll pass in interesting things. Uh-oh, unfortunately, this does not work. And if you look at the error, you'll see it requires string found array of string. So how do you actually pass in an array of existing values to this var_arg parameter? Well, you can do that with the spread operator. And all the spread operator is applying the asterisk before the array variable when you pass it in as an argument value. So now, if we hit run, we'll see that the compiler is now accepting that array, and we are iterating over each item in that interesting things array. So this is how you can pass in an existing collection as a var arg parameter. Another really interesting and powerful feature with Kotlin functions are named arguments. Now let's take a look at an example of what named arguments provide to us. We'll start by clearing out our main function, and then we're going to define a new simple function that will take a greeting and a name and then print that out. So now when we want to call this new greetPerson function, we can say greetPerson, hi, and then I'll use my name here. Now, this is fine, and it's very easy to understand because the IDE is helping us and showing, okay, this is the greeting argument, this is the name argument. However, if you were in a code review, you might not be able to know exactly which order these arguments are supposed to be passed in. Also, if you wanted to modify the function signature of greetPerson down the line, you'd have to make sure that these are in the same order, because since they share the same type, you could mix that order up without getting any type of compiler error. Now, what named arguments allow us to do is specify which parameter this argument value is going to be used for. So what does that actually look like in practice? Well, it looks like defining the name of the parameter and then an equal sign. And then here we can say name equals. And so now we're saying very explicitly, assign hi to greeting and Nate to name. The cool thing that this allows us to do is actually mix up the order of these arguments. So now we can actually pass the second parameter first and the first parameter second. So now we could actually theoretically modify the signature of greetPerson, changing the order of these parameters, and it wouldn't impact the invocations of that function. Kotlin allows us to take this flexibility one step further by leveraging default parameter values. So once again, let's look at our greetPerson example. So here we are now able to pass the arguments in whatever order we want if we're using named argument syntax. But what if we wanted to pass name first and then not even pass in the greeting? Well, now we get an error because it says no value passed for parameter greeting. So as greetPerson is currently defined, it must take both arguments, even if they are in a mixed up order. Default parameter values allow us to change that. It allows us to tell the compiler what the default value should be if none is specified. So for greeting, we could provide a default value of hello. And for name, we could provide a default value of Kotlin. You'll see now, greetPerson can be called by only specifying a single argument value. And if we run this, we'll see it's going to say hello Nate. So it's getting the default greeting value, and then it was using the value for the name that we passed in. Now, because both arguments have defaults, we could actually call this without passing any arguments in. And if we run it now, we'll see it's using both defaults and prints out hello Kotlin. Now, this becomes a really powerful feature because now we can not only mix up the order in which we pass arguments, but we don't even have to pass all of them in. This actually allows us to replicate functionality of the builder pattern without actually having to write getters and setters and have private constructors and all of that. We can configure and reuse functions and objects by leveraging these default values and the named argument syntax. While default parameter values, named argument, and var arg parameters are really convenient and flexible and powerful, they do have limitations as well. So I want to illustrate one of those limitations. So we're going to go back to our say hello function. Let's redefine our interesting things array. And so now if I want to invoke say hello, and I want to pass things in order with the greeting and then the interesting things, I can do that no problem. And if I run this, we'll get our 3 lines of output. And so now, what if we wanted to use named argument syntax? Well, we could do that as well. Greeting equals hi. However, as soon as I add the named argument syntax to the first parameter, I get this error saying mixing named and position arguments is not allowed. So this is one of those limitations. As soon as you use named argument syntax for one argument, everything that follows that must also be named. So in this case, I could fix this by saying items to greet equals, and now I can run this again, and I'll get the desired 3 lines of output once again. Now I could mix these up though. We are using named argument syntax. There are no problems here, and once again, we could run this and we would get our desired output. Now we're going to take a look at how we can create a simple class in Kotlin. Now up until this point, we've been working within a single main.kt file. However, now that we're going to move into classes, let's go ahead and add a new file. So we'll come over to our project panel, right-click source, go to new, Kotlin file or class. Now we're going to come down and on this drop-down, we're going to select class, and then we're going to name this class person, and then hit enter. We can see here then that it automatically has created a person class for us. And I might notice that this class is quite simple. So let's take a look at how this class actually works. To start, we have the class keyword, followed by the class name, and then really that's it. We could actually even optionally remove these curly braces since we're not defining any properties or methods at this time. If we wanted to then use this class, we could return to our main function here, and then we could create an instance of the class like this. So we'll create a variable named person equals person. Now this syntax right here is how you create a new instance of a class. Notice there's no new keyword. In Kotlin, you do not have to explicitly call new. You can simply specify the class name and then the constructor and any arguments that you need to pass into it. So you may notice that we were able to create an instance of the person class using this empty constructor. However, if we go back to our class definition, we don't have any constructor defined. This is because when you're defining a class in Kotlin, if you do not have any properties defined in your primary constructor or any arguments defined in your primary constructor, then you can actually just omit that primary constructor altogether. So what we see here, class person, is really a shorthand form of this. If we wanted to explicitly define this primary constructor, we could do so by adding the constructor keyword and then the open and close parentheses. You'll see here that it actually gives us a message recommending that we remove the empty primary constructor. Now we could also modify this primary constructor by just removing the constructor keyword and moving the open and close parentheses directly after the class name. However, we still get that same recommendation to remove the empty primary constructor. So now let's add a primary constructor once again. And this time, let's actually define a parameter that must be passed into this constructor. So if we're creating a person class, let's pass in a first and last name for this person. So we could say first name, string, last name, string. So now we have two unused parameters that we pass into the constructor. And now if we come back here to the creation of an instance of our person class, we'll see that we now have a compiler error saying no value passed for our parameters. So I'll go ahead and I'll pass in my first and last name here. So now we come back here and we're not actually doing anything yet with these parameters. So let's change that. Let's define our first property on our person class. So since we're passing in first name and last name, let's define properties for first name and last name. So we could say val first name string, val last name string. Now you notice that both of these now have red arrows underneath them saying property must be initialized or be abstract. And there's a couple different ways that we can initialize these. The first way we'll look at is using an init block. You can define an init block by using the init keyword and then open and close curly braces. An init block is a piece of code that is run anytime an instance of this class is run. And you can actually have multiple init blocks that will be processed in the order in which they're defined within your class body. So within this init block, we can initialize our property values using the parameters from our primary constructor. So we'll say first name equals underscore first name, last name equals underscore last name. Now we have initialized properties. If we look up at where those properties are declared, we'll see these little warnings saying can be joined with assignment. What does that mean? Well, this is the other way in which we could initialize these values. We could actually get rid of the init block here, and we could initialize these at the point where they're declared by saying equals underscore first name equals underscore last name. So now we're passing in those parameters to the constructor and then immediately declaring and initializing properties on the class. So now if we go back to our usage of this person class, after we create the instance of person, we can now access those properties. To access the properties, we type person dot, and then we can access the properties by their names directly. So we could say last name or person dot first name. Now you notice that we're not using a getter here. In Kotlin, this is known as property access syntax. You can reference properties directly by their name without having to worry about the getter or the setter. So now if we go back over to our class, we could actually simplify this even a little bit more. And to do that, we'll go ahead and remove these properties. And so now instead of passing in a parameter to the constructor and then defining a separate property that mirrors that parameter, we can actually declare the property directly in the primary constructor. So to do that, we'll come up here, we'll remove this underscore since this is now going to be the property name. And then we'll add the val keyword. And now we have defined a first name and last name properties within our primary constructor directly. And if we go back to our usage, we see that nothing has changed here. We can still initialize the class in the same way and still access our last name and first name properties the same way. So far, we've been working with the primary constructor within our class declaration. But it's also possible to define what are known as secondary constructors. Secondary constructors can provide alternative means for you to instantiate an instance of your class. So let's work with an example. Let's say we want to create a secondary constructor that takes no parameters so that we don't have to always pass values in when we want to create a new person object. So to create a secondary constructor, we'll use the constructor keyword and then open and close parentheses. And in this example, we're not going to pass in any parameters. We then need to call through to the primary constructor. To do that, we use colon and then the this keyword, open and close parentheses. And then now we need to satisfy any parameters that are declared in the primary constructor. So in this case, let's define some default first and last name values. So for our first name, we'll use Peter, and last name, we'll use Parker. And then we can define a body for the secondary constructor. And to just take a look at how this works with the init blocks, let's go ahead and add a print statement here that says secondary constructor. We'll then add an init block, and we'll put a message here that says init1. And then just for fun, let's add a second init block after the secondary constructor, and we'll print out init2. Now, let's run our main function and just see what happens. So in this case, we're using the primary constructor, so we can specify in explicit values for the first and last name. So we'll see that the secondary constructor is never called, but both init blocks are called and logged out to the console. So now let's remove the explicit arguments that are being passed in. And now let's rerun this. And now this time we'll see that init block 1 is run, init block 2 is run, and then our secondary constructor was run. So what this shows is that the init blocks are always going to run before the secondary constructor. Now the init blocks will execute in order in which they're defined within the class body, and then the secondary constructor will be called. Now in this example, and actually in many practical examples when using Kotlin on real projects, a secondary constructor isn't strictly necessary because of the power of default parameter values. So in this case, we could remove all of this within our class body, and instead, we could define default values here in the primary constructor. Now, if we go back over to our usage, we can still use the person class as if it had this empty primary constructor because both parameters have default values. Now let's look a bit more closely at class properties. Now we've already defined two properties within our primary constructor. Both of these are read-only properties, so they have no setter, but they do have a getter available. That getter is how we are able to leverage property access syntax and reference those properties directly as we are doing here in our main function. Let's explore this more fully by adding another property. Let's add a nickname property. In this case, we'll use var because it's not going to be set initially. We'll call it nickname string. And we're going to go ahead and make this a nullable string. And then we'll go ahead and set that initially to null. So now, let's see if we type person dot, we see that we have a nickname property. But unlike last name and first name, this is a mutable property, so we can actually assign a value to this. So we can say equals, and then my nickname growing up was Shades, so we'll assign that string to this nickname property. So if we go back to our person class, let's look at this property a bit more closely. We've already mentioned that properties in Kotlin will get getters and setters generated for them automatically by the compiler. So if your property is a val, it will have a getter generated. If it's a var, it will have a getter and a setter generated. But what if you don't want to rely on the default behavior of these getters and setters? Maybe you want to do some complex logic within that, or maybe you want to log something out for debugging purposes. Well, you can override the behavior of these default getters and setters and provide your own implementations. So let's log out every time a new nickname is set. To do that, we go to our nickname declaration, and then we'll go to the next line, and then we'll space over 4 times. And now, if we start typing set, we'll see auto completion comes up with several options here. So I'm going to choose this bottom one. So what this essentially does is allows us to define the function behavior for when set is called. Now when we do this, this will generate a backing field for this property. So to actually assign the new value to our nickname property, we need to use a special keyword called field equals value. If we didn't make this call, then the value of nickname would never actually be updated. And now we are free to implement whatever we want. So in this case, we could update this with a log message that says the new nickname is $value. So now if we go back over to our main, let's see what this looks like. So we're assigning one nickname, person.nickname. Now let's assign another nickname. In this case, we'll just say new nickname. Now, if we run this, we can take a look at the log. So you see here, each time we're assigning a value to the nickname property, our log statement is being run. Similarly, we could override the default getter. We do this very much the same way. We'll start by saying get. So instead, we'll just log this out, say print line. The returned value is $field. We still have that field backing value, which is what is storing the actual value of nickname. And then we're going to return the value of field. So now we'll come back over to our main. And we'll use a print statement here, person.nickname. And if we run this, we're seeing that our setter is being called multiple times. Then our getter is being called and the value logged out. And then finally, our print statement here in the main function. Now that we've explored class properties, let's take a look at how we can add a method to our person class. To add a method, we really just need to define a function within our class declaration. Let's create a method called printInfo. It'll take no parameters, and it's just going to print out the user's info. So in this case, we'll use a print statement, and then we'll use a string template to print out the first name, the nickname, and the last name. So if we go back over here to our main class, let's go ahead and remove most of this. Now, if we want to call a method on our person variable, we can type person dot and then print info. So now if we run this, we see Peter, null, Parker. So our method worked. However, the formatting is maybe not quite what we would have wanted. Because nickname was null when printInfo was called, we printed out the word null rather than anything possibly more useful. So let's refactor this method a little bit and see if we can improve that. So let's create a variable called nickname to print. And then let's check whether or not this is null. So we say if nickname does not equal null, we'll go ahead and use the nickname. Else, we'll use this more descriptive string of no nickname. And now we can update this implementation. And instead of using nickname directly, we'll use this new local variable. And so now if we go over to our main again and we run this, now we see our output is formatted a little bit better. Now, while the output now looks better, this expression right here is a little bit verbose. This type of check, where we're comparing whether or not something is null and then providing one of two values, comes up quite a bit in Kotlin. And because of that, there's actually a convenient syntax we can use that simplifies this expression. So what we can do is this. Nickname, question mark, colon, no nickname. The question mark colon is what's known as the Elvis operator in Kotlin. What this expression is saying is check what's on the left side of the Elvis operator. If that side of the expression is not null, then go ahead and return that. Otherwise, return what is ever on the right-hand side of the expression. So, if we go back to main and run this once again, we'll now see that we're still getting our updated output. So in this case, the Elvis operator is just a much more concise way of doing that if-else check. Now I want to take a minute and talk about visibility modifiers within Kotlin. Looking at this code here, you'll see nowhere do we have any type of visibility modifier specified. However, if we go over here to our main, we're able to create a new instance of this class. We are able to call the printinfo method, and we are able to access all of the properties. This is because in Kotlin, classes, properties, methods, really visibility in general is public by default. If we wanted to modify the visibility of any of these, we can add one of 4 visibility modifiers. So for on the class, we could add public here. However, because it's public by default, this is not needed. We could add internal. Internal means that this class is public within the module. So in our case, because we're in a single module, this doesn't change anything. We could also make this private. Once we make it private, we'll now see that it's no longer available in our main.kt file. In this case, a private class is only available within the file in which it's implemented. Now we could apply similar rules to our nickname property. If we make this an internal property, nothing changes, and we can still access that. If we make this protected and go back to our main function, we'll now see that we're getting an error. Cannot access nickname, it is protected in person. A protected property or method will only be available within that class or within any subclasses. And as you might expect, if we make this a private property, once again, we cannot access it from our main.kt file. And the same goes for our method. If we make this private or protected, it's not going to be available within main.kt. Now that we have an understanding of how classes work in Kotlin, let's take a look at how interfaces work. So we'll go back to our source directory, go new, Kotlin file or class. This time in the kind dropdown, we'll select interface. And let's go ahead and call this person info provider. And then we'll hit OK. So now the IDE has created a personinfoprovider.kt file, and it's auto-generated this empty personinfoprovider interface for us. Now, like with the class, because the curly braces are empty, we can actually remove those. And this is a completely valid interface within Kotlin. It's empty, there's no methods that can be implemented, and there are no properties that can be implemented. However, this could still be used as a marker interface, for example, and other classes could, in fact, implement this interface. In fact, why don't we do that right now? Let's create a class called Basic Info Provider that implements Person Info Provider. We can actually do that within the same file. We don't need to have one file per class or interface within Kotlin. So to start, we can say class Basic Info Provider. Now we want to indicate that this class is going to implement Person Info Provider. To do that, we'll use a colon, and then we'll type the name of the interface. And just like that, we've now created a new class, Basic Info Provider, that implements Person Info Provider. And because Person Info Provider does not currently have any methods or properties, Basic Info Provider has nothing that it needs to implement. Now let's add a method to our Person Info Provider interface. To do that, we'll come back up to the interface declaration. We'll add back our braces. And now we're going to define a function signature within this interface. Now we don't have to actually implement this, we just have to define the name and the parameters that are required by this method. Now once we've added this, we'll notice down below now that our Basic Info Provider class has a compiler error saying that it does not implement the required interfaces or add the abstract keyword. So let's take a look at how we can address this issue. To do so, we're going to start off by adding a main function so that we can play around with this class. Now, one of the ways that we could solve the compile issue with Basic Info Provider is by declaring it as an abstract class. This means it doesn't need to implement all the methods available on the interfaces that it includes, but it also can't be instantiated. So if we tried to come down here and say val provider equals Basic Info Provider, we'll get an error saying cannot create an instance of an abstract class. So in this case, we don't want to make this abstract because we do want to work with this class. So we can remove the abstract class keyword. And now we want to actually implement the required methods from Person Info Provider. So to do that, we can start typing print info, and the IDE will recognize that. And if we hit enter, it will generate a stubbed out version of that print info method. Now let's take a look at how this was generated. We see that it starts by including the override keyword. This is different than in Java, where it was an override annotation. In Kotlin, if you remove the override keyword, it'll actually give you a compile error. In this case, saying print info hides member of supertype and needs the override modifier. So it's very specific in indicating that you do need to include that override. And then after that, it simply matches the rest of the method declaration from the interface. So here we're now free to define the behavior of this interface however we want. You also see down below that now that we have implemented the interface fully, we can actually create an instance of this class. So if we implement this, right for now, just printing out print info, we can come down to our main function. We can type provider dot, and then we can invoke the print info method, and we'll pass in a empty instance of the person class. And we'll see here that it executes that print info method. So that's a very simple example of how we can define an interface, define a method on that interface, implement it, and then run it on that implementing class. Let's improve upon the implementation of print info. So here we're going to say basic info provider, and then below that we're actually going to call the print info method on our person class. So now if we run this, we'll see that we have that basic info provider being printed out, and then the info from the person. Now perhaps we want to encapsulate this logic within the interface itself. Maybe this print info method should always generally work in this same way. Well, we could actually move the implementation that we've just defined right here up into our interface. See, in Kotlin, interfaces can provide default implementations of an interface method. So now we can actually remove the implementation of print info from basic info provider, and the code will still compile and run. So now if we run this, we're going to get the same output. However, there's an issue with this. We see now in our person info provider interface, we are including the basic info provider string. Well, we probably don't want that since it is an implementation detail of basic info provider. So here we could actually leverage another interesting feature of interfaces in Kotlin. We can provide properties on our interfaces as well as methods. So we'll define a property called provider info of type string. Now you might be tempted to give this a default value, but if you do, you'll see that we actually get a compiler error saying property initializers are not allowed to interfaces. So you will, in fact, have to override this in any implementing class. But now that we have this provider info string, we could modify our print info default implementation to print out that provider info. So now we've kind of encapsulated this logic into the interface itself, and then the basic info provider class can now just override that provider info property. And we override a property in much the same way as a method. So we'll use override val provider info of type string, and then we have to provide the getter. So in this case, we'll say basic info provider. And now if we run this once again, now we'll see that we are picking up the overridden property value and then still relying on the default implementation of print info in person info provider. And now if we wanted to still override print info, we could absolutely do that. And we could call through to the super implementation if we would like. And then we could print out anything else here. We are now relying on the property, the default implementation of print info, on the property, the default implementation of print info, as well as now our additional logic and the overridden implementation of print info. Next up, let's look at how we can implement multiple interfaces with a single class. To start, we'll add a new interface called session info provider. And then we'll add a method to this called getSessionID. And that will return a string. And so now if we come down to basic info provider, we want to make this class implement session info provider as well. Well, all we have to do is to add a comma after the previous interface declaration, and now add session info provider as well. And now once we do that, we'll now see basic info provider telling us that we don't implement the required methods. So we can come down here and implement getSessionID, and we can return some session ID. Now down here on our provider class, we can now see that we can call getSessionID on our basic info provider instance. Now's a good time to talk about how type checking and type casting work in Kotlin. To do this, we're going to create a new function here called checkTypes, and we're going to take a parameter of type person info provider. Now, let's say that we want to check whether this person info provider is also an instance of a session info provider. How about we go about doing that? Well, we could say if info provider is session info provider, and then we'll print that out. Say is a session info provider, otherwise println not a session info provider. And now we will call this check types function, and we'll pass in our provider variable. So now if we run this, we'll see is a session info provider printed out to the console. So this conditional was able to determine that the passed in info provider was also an instance of a session info provider. Now if we wanted to flip this logic and check that it is not a session info provider, we can add an exclamation point before that, and then we'll just flip these print statements here. And now, once again, if we run this, we'll see is a session info provider. So you have the flexibility there to check that either way. Now let's take a look at how typecasting works. So within this else block, we've already checked that info provider is a session info provider. So we could cast it and then call methods on it as if it was a session info provider. So we could say info provider as session info provider. The as is the keyword used to cast something to another type, dot get session ID. So now we're able to cast info provider as that session info provider and call any methods or access any properties on it that are specific to session info provider. Now, Kotlin also includes what's known as smart casting, which means that if the compiler can check a type and validate that that type will not change, then you don't need to do any additional casting. So in this case, we've already validated that info provider is a session info provider. So we don't actually need to explicitly recast this. We could say info provider dot get session info, and the compiler is performing a smart cast for us. So here we can access get session ID or other properties and methods on the session info provider without having to explicitly cast it each time. We've now seen how a class can implement multiple interfaces, as in the example of our basic info provider. Let's now take a look at how a class can inherit from another existing class and override methods and properties on that base class. To start, let's create a new file called Fancy Info Provider. Within this file, we're going to create a new class called Fancy Info Provider. We then want this class to extend the basic info provider that we already defined. So we can do that by adding a colon and then typing the name of the class that we want to inherit from, in this case, basic info provider. Now, as soon as I do this, you might notice that we have a red squiggly line here indicating an error. The error says this type is final, so it cannot be inherited from. This is a characteristic of classes in Kotlin. By default in Kotlin, classes are closed, meaning they cannot be inherited from or extended. To extend this basic info provider class, we need to add the open keyword. By adding the open keyword, it now means that you can inherit from this class. So if we go back to our fancy info provider, you'll now see that our error has gone away, and we can now override methods and properties in this class. Now let's start by overriding the provider info property. So we'll add the open and closed curly braces to our class definition. And then I can start typing provider info. You'll see that the IDE is suggesting the property available to us to override. So I'll hit enter, and that will go ahead and auto-complete the property. Now notice it has the override modifier indicating that this property is being overridden. And now you'll notice that it automatically provides a custom getter, and you'll see that it defaults to deferring to the super implementation of this. So we could actually override this just like this by saying fancy info provider. If we were to then come back to our main function here and replace this with an instance of fancy info provider, and we rerun this, we'll now see that it is printing out fancy info provider, so that provider info is being correctly overridden in our new extended class. Now let's try overriding the print info implementation in our fancy info provider class. So if I start typing print info, once again we'll see the IDE suggesting the method that can be overridden. I'll hit enter, and again by default this will call through to the super implementation of print info within basic info provider. And so I could then add another line here that just maybe says something like fancy info. And if I come back and run my main function, and now we'll see the base implementation, the basic info provider implementation, and now this extra line added by our implementation of fancy info provider. Now I want to illustrate one last point in regards to inheritance, but before we do, let's refactor basic info provider a little bit. Instead of hard coding the session ID here, let's add a property to hold that value. So we'll come here and we'll say val, and we'll say session ID prefix, let's say, equals session. And now we will return session ID prefix right here in our implementation of get session ID. So now, if I come into fancy info provider, I want to override that new session info prefix. So to do that, I might start typing session, and you'll notice that it's not auto-suggesting that new property that we just added. This is because to override a property in a derived class, you have to mark that property as open. This is just like extending a class. So we can come here to session ID prefix and add the open modifier. As soon as we do that, if we start typing once again, now we'll see it's suggesting the option to override session ID prefix. So just like the provider info property, I can now override this, and I could say fancy session. So this is just one other way in which Kotlin works to enforce immutability. It forces you to mark both your classes, your properties, and your methods as being explicitly open for extension. Now there's a small problem with this new session ID prefix that we've added. It's really meant to be an implementation detail of the class. However, if we come here to our call site where we're using a fancy info provider variable, you might notice that we can actually access that prefix directly. This isn't ideal because, like I said, it's an implementation detail. Our API shouldn't really be exposing that property. Now, the reason it's available is because we have defined it as a public property. So what can we do about this? Well, if we want it to be available in our child classes, but not to the public API, we could add the protected modifier. So now that that property is protected, down here when we try to access it, we get an error saying cannot access session ID prefix. And if we come back to fancy info provider, you'll see that we can still override that property without any trouble.
Now that we've explored how we can extend an existing named class, let's look at how we can create an instance of an anonymous inner class using an object expression. To do that, we'll come over to our main function here. And now instead of instantiating an instance of fancy info provider, we're going to create an anonymous inner class. So we'll delete that. And to start off, to create our object expression, we can type object, colon, and then the name of the class that we want to extend. In this case, it'll be person info provider. Now within this class body, we can override any available properties or methods. So in this case, I'll update the provider info and just say something like new info provider. Now notice below here that our provider.getSessionID call is now being marked as an error. That's because there is no getSessionID on person info provider, but we could go ahead and add a new method to our object expression here. So we can just say fun get session ID equals, and then we'll just put in a value here. So you see you can not only override the existing properties and methods, but you can add to them as well, just like you could in any other named class. And now if we run this code, we'll see new info provider being printed out to the screen. So an object expression allows you to create an anonymous inner class so you don't have to create a new named class. So this might be useful for things like a click listener if you were working in, let's say, Android development. Now that we've explored object expressions, we're going to now look at companion objects. And to do that, we're going to create a new file. We're going to name that file Entity Factory. Now imagine we want to create a factory to create instances of something called entity. So to start, we might create an entity class, and maybe that class will have a single ID property to start. Now we want to make this a factory like we said. So what we might want to do is change this constructor to be private. And so now if we add a main function and we try to create an instance of entity, we'll see that we have an issue here. We'll notice that there is this error saying cannot access init. It is private to entity. So this is because of that private constructor. Well, so what can we do? This is where a companion object could come in handy. A companion object is an object scoped to an instance of another class. So within our block body here, we can type companion object. Now we could create a create function called fun create, and we'll have that simply return an instance of entity. And for now, we'll just pass in a placeholder ID. So now we can come back down to our main function and we can type entity.companion.create. And we can use this to create an instance of that class. This works because companion objects have access to private properties and methods of that enclosing class. Now in this case, we can actually shorten this by removing the reference to companion altogether. The name companion is implicit, and if you're using it from Kotlin, you can leave it off. However, if you were using this companion object from Java, you would have to reference that companion object instance directly. You can also rename your companion object. So if we wanted to name this something like factory to be a bit more explicit, we could then say .factory and reference it that way. And so again, not needed from Kotlin, but it could be a good way to make your code more understandable from the Java side of things if you're doing a lot of Java to Kotlin interop. We can also store properties within our companion objects as well. So in this case, we could create a const val ID equals ID, And then we could come down here and replace our entity and pass that in. Now that we have this ID property added to our companion object, we can reference it from other calling code as if it was a static property like we're familiar with from Java. So we could do that by typing entity dot, and then we can reference that ID property directly. Now, companion objects are like any other class in that they can also implement other interfaces. To demonstrate that, we'll create a new interface called ID provider with a single method just called getID that will return a string. Now we can come down to our companion object declaration, and we can make it implement ID provider the same way we would with any other class. We can then choose to implement the required members. And then here we will just return a simple ID. And so now when we create our instance of ID, we could rely on this getID method if we wanted. So you see, companion objects can be quite flexible if you need them to. You could use those to compose other types of behavior, store your semi-static properties or methods, and use them to create factories by referencing private inner properties or methods of the enclosing class. This is really what you would want to leverage if you want functionality similar to that of static classes, members, and fields from the world of Java. Now that we've covered object expressions and companion objects, let's take a look at creating an object declaration. To start, we're going to clean up some of this code we've been working with. So we will remove this implementation of ID provider, and we will go back to using a placeholder ID. We'll remove this reference to entity ID, and we can remove this ID provider interface. Now, what are object declarations? An object declaration is a convenient way of creating thread-safe singletons within Kotlin. We can do this by using the object keyword and then a class name, in this case, entity factory. Now within this, you can add any types of properties or methods that you would like. So let's start by migrating our create method from our companion object into our entity factory. And now we can remove that companion object, and instead we can reference entity factory dot create. Now there's one small problem with this so far, which is that entity still has only a private constructor. Now we're going to remove that private modifier for now so that we can use that constructor. However, very shortly, we will continue to refactor this code to limit the ways in which entities can be created. Now, before we go on and continue to explore some of these other class types in Kotlin, let's add to our entity class by implementing toString so that if we print out an instance of entity, we get some nice user-readable text. So we can start typing toString, and then I'll use a string template here, and we'll say ID : is ID, and then we will also add in a name property here, val name of type string, and then we'll say name, and then substitute in that name property. And then here in our create method, we will just put in a generic name. And now down here, we can use a print line statement and pass in our instance of entity. And now we see our new toString text being printed out to the console. So this will help us going forward demonstrate some of how these other classes are going to work. All right, now that we can print out useful information about an instance of an entity, let's refactor our create factory method to actually differentiate instances of entity. So to do this, we're going to change this and make it no longer a single expression function. So we will add the return type of entity, and then we'll add a return keyword, and now we'll add entity. Now the first thing we want to do here is actually add a proper ID value. So here we could say val ID equals udo ID dot random uuid dot to string. So this will give us a new random identifier, and then we can pass that into our entity. But now we have this name property. So what can we do to pass in a name here? Well, one thing we might do is think about differentiating between different types of entities. So in a very basic case, maybe you want to differentiate between easy, medium, and hard difficulties of these entity types. So we might want to then have some way of passing or indicating to this factory method what those different types should be. So one way we could do this is with an enum class. Now, if you're familiar with Java, an enum class is going to be very similar to what you're familiar with from enums in Java. To do that, we can start typing enum and then class. And then in this case, we might name this something like entity type, then open and close curly braces, and then we can iterate the different instances of the enum. So in this case, we might say easy, medium, hard. So now we can come down here to our create method, and then we can add a type parameter of entity type. And so now we could say val name equals when type. And then we're going to add in the remaining branches. So now we have a branch for each of our entity types. And then for a basic name, I'm just going to map these to a string. So we'll say easy, medium, and hard. And so now I can pass in that name. So now our factory method actually allows us to differentiate and create different types of instances. Down here, we might start off by creating an easy entity, and then we'll print that out. And then we might say val medium entity equals entity factory dot create entity type medium. And then we can print that out as well. And if we run this, we'll now see that we have a unique identifier for each entity, and then we have the customized name based on that entity type. So the addition of this enum class to represent our entity type has allowed us to pass in different types to our factory method, and then customize the way that those entities are created by mapping the entity type to a name. Now in this case, we're mapping the name very closely to the name of the actual class itself. So to make this a little bit easier and more encapsulated, there's a couple of things we could do. So the first thing we could do is take advantage of the name property on an enum class. So to do that, we could reference our type.name. So this is referencing the name of that actual enum class. And if we run this, we can see what that name looks like. So you see, it's easy, all in capital letters. This matches exactly the way that the class name is actually defined. So this allows us to reference the class's name directly without having to map it manually. Now this is nice, however, we don't have a lot of control over the formatting here. So another thing we could do is actually add a new method to our enum class. So in this case, we could add fun, get, formatted, name, and then we could reference that name property dot to lowercase dot capitalize. So this will return us that pre-formatted name and capitalize the first letter. So now down here, we could update our medium mapping and type type.getFormattedName. And so now if we run this code again, we'll see that the first one, by using the name property directly, is all capitalized. But now by using our new formatted method, we have a nicer formatting, similar to what we were using before. So this is just one example of how you can define an enum class and then add additional properties and methods to that class like you would any other class. Now let's continue refactoring this code to further differentiate between different types of entities. To do that, we're going to leverage a sealed class. Sealed classes allow us to define restricted class hierarchies. What this means is that we could define a set number of classes all extending a base type, but those classes will be the only ones that can extend that base type. So one example of this could be a loading state or a result state for a network operation. It's either going to succeed or fail, and there aren't really any other options. So in our case, we're going to create a sealed class with an easy, medium, hard, and help entity types. To start creating our sealed class hierarchy, we're first going to remove the properties from our entity class, as well as this existing override of the toString method. The next step is to add the sealed keyword before the class keyword in the entity class declaration. As soon as we do that, we'll start getting an error above where we try to create an instance of entity. This is because you can't instantiate base sealed class types directly. So this is now where we will create each type within our sealed class hierarchy. So the first type we're going to create is a data class to represent easy entities. And then we will add the properties we want, in this case, the ID and name. And then we want to make sure that we inherit from entity. So next up, we can copy that and update the name for the medium type. And now for the third type, once again, we'll copy that. We'll name this hard, but now we're going to add an additional property. This property will be called multiplier and will be a float. And this could represent some type of difficulty multiplier if we were creating a game, for example. Now notice that all of these types within the sealed class all extend from entity, but have different types of properties. This is one of the key differentiators between sealed classes and enum classes. With sealed classes, you can have different properties and methods on each of these types, and the compiler can perform smart casting to allow you to use these different properties and methods as you would like. We can also use different types of classes itself within our sealed class. So you notice that these are all created as data classes. However, if we wanted to remove data from one of these, that would be perfectly fine. We could also use object declarations within our sealed class hierarchy. So in this case, we'll create an object class called help to represent some type of generic static help entity within our program. Now, because help doesn't have a constructor because it's static, in this case, we can add a class body and we could add a name and add help directly. And in this case, we won't add ID since it's a singleton and there's only going to ever be one instance anyways. Now that we have our sealed classes defined, we're going to update our factory method to instantiate and return different types of entity classes. So we'll come up here to our return statement, and instead of returning an entity directly, we're going to use a when expression based on the entity type enum class. We'll then add all of the needed branches. And so when we have an easy type, we want to instantiate an instance of the easy class. So to do that, we'll type easy, and then we will pass an ID and name. And similarly, for medium, we'll type entity.medium, ID, name. And now for hard, once again, we'll pass in entity.hard, ID, name. But now again, we have this additional property type, and the compiler recognizes that. So for now, we'll just pass in 2f as our multiplier. Now notice though that we have this help entity being unused. So let's update the factory to allow us to create instances of the help type. So we'll come up to our entity type enum class and add a help type here. Now notice as soon as we added that additional type on the entity type enum class, our when expressions warn to us that we need to add an additional branch. So to do that, I'll add the remaining branch here, and I'll default to type.getFormattedName. And once again below here, I'll add the remaining branch. And in this case, I'm just going to return help directly. You'll notice here that help is giving us an error. It's saying required entity found entity.help. This was done to demonstrate what happens if you do not extend from the base entity type. So if we come down to our entity class here and notice our object declaration for help, if we then add a colon entity to extend from entity, we'll now see that error go away. So this is a good example of how the compiler can help give us this nice static type checking and all of these things. And if we are combining enum classes with sealed classes with these when expressions, it allows us to be sure that if we add a new type or a new branch somewhere, that we have to handle that effectively, because the compiler will warn us or even give errors if we're not handling all of those different branches. Now let's come down to our main function and demonstrate one of the advantages of representing our entities as a sealed class hierarchy. So if I remove everything but this first instance of creating an entity, I'm going to specifically add a type here of entity. Now we can come down here and use a when expression to do some type checking about the entity that we have just instantiated. So here I'll say val message equals when entity. And now again, we're going to rely on the IDE to add all the remaining branches. And so there's a few things of interest to note here. So we'll see that for easy, medium, and hard, it's adding this is check. So this is going to basically tell if it's an instance of that class or not. But then notice for the help class, because that's an object declaration and is a singleton, there's no need to have is. So in that case, we can reference that class directly. And so now here, we could add whatever message we wanted. So we could say help class, easy class, medium class, and hard class. And then if we simply print that message out and run the code, we can see in this case, we're getting an easy class. And then if we change what we pass into our factory method and rerun this, we'll now see that we're getting the help class. So now we have static type checking both in specifying what type of entity we want back and in checking the type that we're actually getting back from that. And so we could use this to then call any methods or properties that are specific to that class. And if we were operating on these types, as in a when expression here, if we ever added a new type, the compiler would be sure to make sure that we handle the addition of that new type. So now let's return to our sealed class hierarchy for a second and dive more deeply into what data classes are. So you see here both easy, medium, and hard are all defined as data classes. Data classes are Kotlin's way of providing very concise, immutable data types. By defining a class as a data class, it means that it is going to generate methods such as equals, hashcode, and toString automatically for you. What this allows us to do is perform equality comparisons on instances of these data classes and treat them as equal if the data they contain is equal. So as an example, let's explore what this looks like. So we can say val entity1 equals entity factory dot create, and we'll create an easy entity. And then we're going to create another version of this. And then now we can check their equality comparison. So we can say if entity1 equals entity2, println, they are equal, else println, they are not equal. So now if we run this, what will we see? They are not equal. And that's to be expected. That's because if we come back up to our factory, we'll notice that we're creating different unique IDs each time. So even though the name is the same, the unique ID is different. So now let's update this and see what it looks like if we pass the same data in. So in this case, we could create an easy directly. In this case, we'll pass in ID, comma, name. And then we will duplicate this for entity 2. Now if we run this, we're going to expect to see they are equal. And of course they are. So this is really convenient. This allows us to represent data within our applications and compare this data no matter where it comes from. And as long as those properties are all the same, we're going to be able to evaluate these as true. Now, another really interesting thing that data classes give us are effective copy constructors. So we could create an instance of entity 2 by copying entity 1. So you can see entity1 dot copy. And because this is a direct copy, if we run this once again, we're going to see they are equal. However, we could also use named arguments with the copy constructor to change the value. So let's say we only wanted to change the name. We could say name equals new name. And once again, if we rerun this, we're going to see they are not equal. So you can see changing a single property in the data class is going to impact whether or not two instances evaluate to true or not when compared. Now, one thing to notice is this is comparing the value of the data themselves. If we wanted to use referential comparison, we could add a third equal sign here, and this will check whether or not it's the exact same reference or not. So in this case, they are not equal. However, this isn't all that surprising since the data was also equal. So what about if we revert this and make this an exact copy again? So before, if we were just using two equal sign, the data would be the same, so it would print they are equal. However, by using three equal signs and using referential equality, we see they are not equal. That's because it's not the same exact reference of the object. If we updated this to be entity1 equals entity1 and run this, now we'll see they are equal. So that's just one way in which we can check whether or not we have the exact same object or if it's two different objects that have the same data. Now also keep in mind that these equality comparisons are working off of the generated equals and hash code methods generated by the compiler when indicating a data class. However, we could update this to change how the equals or hash code is evaluated. And to do that, we would do it like any other class. We could add a class body, and then we could simply override equals and or hash code. Now, as in Java best practice, if you're going to override one of these, you should really override both of them, and you have to follow the same rules, but you have that freedom if you would like to. Another really useful feature in Kotlin is the ability to define extension functions or extension properties on an existing class. This is particularly powerful if you're working with classes that you don't control, but would like to modify the way in which they are used. You could define your own properties and methods and define kind of a new API around the existing class. So an example of this would be adding a new method to the medium class without actually defining that method within the definition of the medium class. So to do that, let's come down here, and you can start off by typing the fun keyword, and then instead of directly typing the method name, we can reference the class name dot, in this case, we'll type print info, and then we can define our function body. So in this case, we'll just say medium class with the ID, and that'll be it. And so if we wanted to come down here and now create an instance of entity.medium directly, we could do that. And then we could call that print info method. And if we run that code, we'll see medium class and then that ID printed out. So this is great if we know that we have that exact type that we're working with. And in cases where we don't know if we have that direct type, we could rely on smart casting. So if we update this to use our factory, say entity factory, create entity type medium. Now we could say if entity2 is medium entity, now we can reference that new print info method. This is done because the if statement will only evaluate to true if that cast is successful. So anywhere within that context, it will automatically perform the smart cast for us. But we can also define extension properties as well. To do that, extension properties as well. To do that, we could start off by saying val or var. In this case, we'll say val. And then again, we'll reference the class type. So medium dot, we'll say info will be this property name, string equals some info. If you do that, notice that we have this error. If you look, it says extension property cannot be initialized because it has no backing field. So to actually create an extension property for an existing class, you need to rely on backing fields. Thankfully, the IDE can generate this for us, convert extension property initializer to a getter. So once we do that, you'll notice here that we have still defined our property, but now we're relying on this custom getter for that property. And so now, if we come back down here within our if statement that's doing our smart cast for us, we could reference that new info property directly. So this is how extension functions and properties work. You could use these anytime you want to add additional functionality to an existing class. You might notice within the Kotlin standard library that many functions and operations work by using extension functions and classes. They are particularly effective when using them with templated types because it allows you to define the same common functionality across any type that matches that template. So now we're going to circle back to functions and specifically take a look at higher order functions and how to work with functional data types. Now, what are higher order functions? Higher order functions are functions that either return another function or that take functions as parameter values. Now, much of Kotlin's standard library is built on top of higher order functions. And it's what really allows us to write highly functional code by leveraging that standard library. So let's take a look at how we can write our own higher order function. To start, we have a new Kotlin file, and we're going to define a new function. So we'll call this fun, and then we're going to call this print filtered strings. And now the first argument to this is going to be a list of strings. So we'll call this list, and then define it as list of string. And now the next thing we're going to do is define a parameter, which will in fact be a function. That function will take in a string and return a Boolean. We can then use that to filter out values in the past collection. So to define a function parameter, you can start off by defining the parameter name as usual. In this case, we'll name it predicate, followed by a colon. And now you have to define the type as you normally would. To define a functional type, you can start by adding your parentheses. This will define the parameters of the function being passed into your other function. So in this case, we are going to take a string. You'll then add the arrow, and then you want to define the return type. So in this case, that will be Boolean. And now I'll add the open and close curly braces to define our block body. So now we have a parameter called predicate, which will be a function that takes in a string parameter and returns a Boolean. Now we can implement our print filtered strings function to make use of that predicate function to filter out any strings in that past list. So to implement this function, first off, we want to iterate over each string in the past list. So to do that, we could say list.forEach, and now we will be able to iterate over each of those strings. So now what we want to do is evaluate the predicate for each string in the collection. So we can call the predicate function in several different ways. So to start, we'll say if, and then the easiest way to invoke the predicate is to simply say predicate, open and close parentheses, and pass in the parameter value. A parameter that is a functional type can be called as if it was a regular function, as long as you can satisfy the required arguments. So in this case, we can say if predicate returns true, then we can print out that string. Now to test this, we'll come down here and we will add a main function, and we will say val list equals list of, and then we could say something like Kotlin, Java, C++, JavaScript. And now we could call print filtered strings, pass in our list, and now we need to pass in a function as the second parameter to print filtered strings. So we can do that by specifying a lambda, and in this case, we will say it.starts with k. So this lambda is going to evaluate to true if any of the past strings begins with a k. Now, if we run this function, we'll see only Kotlin printed out to the screen. If we were to update this to print things out that started with a J, we'll now see JavaScript and Java. Now, one thing to notice is that in our invocation of print filtered strings, we've passed our lambda within the parentheses of that function invocation. However, this is something that we don't have to do. As we mentioned earlier, we can take use of lambda syntax, which says that if the last parameter of a function is a function, you can specify that as a lambda outside the function body. So we can restructure our function to look like this. We can pass in the list first and then specify our lambda outside of the parentheses. So this is actually very similar looking to the forEach function, which we called up above. And in fact, if you look at the implementation of forEach, it is in fact a higher order function. The lambda that we specify after invoking forEach is a function which will operate over each string in that list. Now, if we come back up here to our implementation notice that we are calling the function parameter directly as if it was a regular function. So this works absolutely great in most situations. However, if we were to make this function type a nullable type by wrapping it in parentheses and adding a question mark, we'll now see an error in our implementation of print filtered strings. That error basically says that you cannot invoke that function parameter by using the parentheses directly if it's a nullable type. To get around this, we can make use of the invoke method on that functional type. And then we can make use of the safe call operator. And now by updating this to do a safe invoke call on the predicate function, we can handle this whether or not the predicate is null. Calling invoke will invoke the function just as it would any other invocation of a function. So now, down here, nothing has changed in how we can call print filtered strings. However, we could also pass in list, and now we could pass in null as a null function. So we've seen how we can treat functions as parameters to other functions. And these function parameters are really treated as types, just the same as, let's say, integer or string. Kotlin has this idea of functional types. It's a first class part of the language. This means that we could define a variable of a functional type and then pass that variable in anytime we needed a function parameter that matched that function signature. So an example of this might be something like val predicate, and then we will define our function type to match that of our print filtered strings function. So in this case, it'll take a string and return Boolean. And now we will define our function the same way that we were doing it before by saying if the string starts with a j, go ahead and return true. Now, instead of invoking print filtered strings with a lambda passed to it, we can pass in our predicate variable directly. And now if we run this, we'll see the same output as we would before. So this allows us to store functions as variables. This could be really useful for things like optional input handling. For example, maybe you have a view on some screen and you want to be able to specify a click listener for that view. You could define that as a lambda property on some class and allow client code to set that click listener as needed. As we mentioned before, higher order functions include functions which take other functions as parameters, as well as functions that return other functions. So let's define a function called get print predicate, and it'll take no parameters, but we can define its return type as a function which takes a string and returns a Boolean. And now we could return that value by saying return, and then we could pass a lambda and say it dot starts with j. So we're passing essentially the same type of lambda that we've been using in these other examples, but now we've wrapped it in this other function. And so now, instead of passing predicate directly, or instead of defining a new lambda as our function parameter, we could instead call get print predicate as a function on its own, which will then return a function, which then can be used as the predicate for print filtered strings. And if we run this once again, we'll see that our output hasn't changed at all. So higher order functions can work as both inputs and outputs. And Kotlin allows you to define properties with functional types. So through this, functions really become a very powerful and first-class part of the language that can start to replace a lot of other instances. For example, you might find yourself relying more heavily on functions to define things like event or click listeners, rather than defining concrete interfaces for those same types of functionality. Now, as was recently mentioned, much of the Kotlin standard library is built around higher order functions, and especially higher order functions defined with generic types. So if we look at the implementation of for each, we'll notice that this is actually an extension function as well as a higher order function. So for each works on generic iterable type and takes in a function parameter that takes in that generic type and returns unit. So this essentially allows us to iterate over each element in the collection and then call that action on it. And it doesn't have to return anything. And similarly, for each index takes in a single function parameter as well, but this one takes in an int to represent the index as well as the generic type. This allows us to iterate over each element in the collection while incrementing a counter and then passing that counter into the function parameter as the index. The power of generic types, extension functions, and higher order functions allows us to write single implementations of these methods and then reuse them over any type that we can think of. Now, this is very powerful and can allow us to write much more functional code without having to redefine these methods and functions for all of our different types. So let's take a look at an example of how we can combine some of these different functional operators to perform complex operations with very little code. We'll come into this new main function here, and we'll start off by defining a list of strings once again. So as we've seen before, we could do a simple for each to iterate over each item in this collection and print it out. And if we run it, we'll notice that we see all of the programming language printed out to the console. Now, what if we wanted to print out only the strings that start with J? Well, similar to the functions we were working with before, we could do that by making use of a filter operation. So we have a lot of options to choose from. In this case, we will just choose a generic filter, and then we will use a predicate which says it dot starts with J. And now if we run this, we'll see we have only Java and JavaScript printed out. Now, what if our collection included some null values? So as soon as we add null, we see now here in our filter operation, it's warning us that, hey, this value might be null. You need to add a safe call. Well, in Kotlin, oftentimes we don't want to work with null. We want to try and hide null as much as possible. And so we could make use of another functional operator called filter not null. What this does is immediately filter out any null values up front. So everything past that in the functional chain will be guaranteed to be not null. So as soon as we added filter not null, we no longer had to deal with a possible null string. And if we run this once again, we'll see only Java and JavaScript printed out. Now, what if we wanted to change the type of this? Let's say we wanted to convert this from a string to an integer, which represents the length of that input string. We could do this type of transformation using a map function. The map function will take in whatever the previous type is, in this case string, but it'll allow us to return any other type we want. So in this case, we might define our map function as simply returning the length of the string. As soon as we've done that, now below that in the for each, the type has changed from string to int. And now if we print this out, we'll see 4 and 10 printed out. 4 representing the 4 characters in Java and 10 representing the 10 characters in JavaScript. Now let's remove this mapping and let's remove the filter. And instead, let's imagine that we want to take only a certain number of items from this collection. So we could do that by using the take function and passing in, let's say, 3. What that'll do is we'll take the first 3 items from that collection, and then we'll be printing out each of those 3 names. So you see in this case, we're getting Kotlin, Java, and C++. Alternatively, if we didn't want to take the first 3 elements in the collection, we could use take last to take the last 3. So in this case, we see Java, C++, and JavaScript, and it has skipped over Kotlin since that was not one of the last 3 elements. We can also do other transformations, such as associating the input values with some other value to return a map. So let's create a map that essentially maps the string to the number of characters in that string. So to do that, we could say associate, and then in this case, we could say it to it dot length. And so now in our for each function, instead of iterating over strings, we're iterating over map entries of string and int. So in this case, we could now use a templated string and say it dot value, comma, it dot key. And if we print this out, we'll see the length, comma, followed by the name. This makes it really easy to map all of the input strings to some other value and then iterate over that map. Now, what if we didn't want to iterate over the map, but instead just wanted to hold on to that in a variable? Well, instead of using a for each at the end, we could assign this to a variable just like this. The Kotlin standard library also provides a variety of functions to help us pull out individual elements from a collection. To demonstrate that, let's create a variable called language, and then we're going to perform different operations on our list to grab a single language string from our list. So we could do that in a number of ways. We could say list dot first, and if we print this out, we'll expect to see Kotlin, as that is the first language in the list. Alternatively, we could say list.last. And in this case, you'll see that it's actually printing out null, since null was the last value in that list. Now, if we didn't want to retrieve a null value from our list and instead wanted the last non-null value, once again, we could add the filter not null function, which we used previously. And now, if we rerun this, we'll see JavaScript printed out instead, since this is the last non-null value. Now, what if we wanted to find a specific item in the list? Let's say we wanted to use the find function. And in our predicate, we'll say it dot starts with, and we'll pass in Java as a string. So this is going to find the first value in this list that starts with Java. So in this case, it actually returns us Java. And alternatively, we could use find last to find the last element in the collection that matches this predicate, in which case it's going to return JavaScript. Now, what happens if we are searching for a string which doesn't match our predicate? We could test that by looking for a string which starts with foo. If we then run this, we'll see null printed out to the console. This is because there is no matching string. So find last is going to return null, and then the print line statement will print out null if it has a null value. Well, what if we didn't want to work with null? What if instead we wanted to use an empty string as the placeholder? Well, strings in Kotlin have a useful function called orEmpty. So we could actually chain that directly off of find last here and call orEmpty. So what this will do is return either a non-null string or a static empty string. So now, if we run this once again, instead of null, we're just seeing empty. We're not printing anything out. So this is one way in which you could default your collections or your strings to an empty value as opposed to a null value. And this is something you might want to consider doing more and more of in Kotlin as you start to move away from relying on null. So as we've seen, Kotlin has first-class support for functions, including functional types and higher-order functions. And the Kotlin standard library builds upon those tools and provides a rich set of functional operators for us to use. This allows us to build powerful functional chains to transform our data and make complex workflows much simpler.